Hey everybody, we're here looking at the conceptual motion practice problems. Number one, what two controls in a car cause a change in speed? Well, we know we can either increase speed or decrease speed, and that we can use for increasing speed or decreasing speed, that is acceleration, right? So that is technically the accelerator, right? Also known as the gas, right? The gas pedal. Right, step on the gas, let's increase our speed. Or let off the gas and let's decrease our speed a little bit. Oh, the brake will do that too, right? So gas pedal or the brakes. The gas pedal will increase your speed, a positive acceleration rate. The brakes will decrease your speed and have a negative acceleration rate. All right, what control causes a change in velocity? I don't know if the video did this super well, but velocity is actually speed, how fast you're moving, and also the direction you're moving in as well. So you could be driving straight down the road and have a constant velocity and going straight. But the moment you turn and change direction, you're going to change your velocity. So the control in the car that will change your direction is obviously the wheel, the steering wheel. All right. Number two, Usain Bolt runs the 200-meter sprint in 19 seconds. What was his average velocity? Did he ever run faster or slower? And to explain. Let's see, in class we saw the 100-meter, but he also ran the 200. So to find the average velocity for that, it's just distance or change in position, delta x, over change in time, which is our t. So he's running 200 meters this time in 19.19 seconds. And if you grab your calculator for a moment. All right, I just did that. That is 10.42 meters per second. All right, so obviously he ran slower than that in the race out of the starting blocks because his velocity was 0. So slower when starting. And he ran faster than that average velocity. Well, remember, that average velocity is like a sum of every velocity he ran the race with. So I would assume he ran faster kind of during the race, or technically like 2/3 of the way, or maybe 3/4 of the way down there, and reaching his top speed and maintain that top speed to try to win. Well, he did win. All right, number three, a cheetah can run up to 28 meters per second. That's like 50, 60 miles per hour, everybody. How far can it run? How far can it travel? So how far if it maintains that speed for 5 seconds, right? There's some crazy YouTube videos of cheetahs on the run, on the hunt, I should say. So let's see, this sounds like if we assume the cheetah is going to run at an average velocity of 28 meters per second, and average velocity is just distance over time. So if that cheetah can go 28 meters per second constantly for 5 seconds, here's my 5 seconds, I want to know the distance, right? So obviously I have to cross multiply here. So the distance is just going to be 28 meters per second times 5 seconds. And if I get my calculator, I'm not going to hit pause, I'm going to do it real time. 28 times 5 is 140 meters, folks. All right. Number four, when you're moving at a constant velocity in a car, how does the distance change as you're traveling with time? I'm just going to move these up here. So if I travel at 14 meters per second for 5 seconds, how far does my car travel each second? Well, that's what average velocity means, right? Average velocity, if it's 14 meters per second, it means your car is really going to travel 14 meters every second. That's what the little per sign means, right? The little slash. So that means I go 14 meters for the first second, then another 14, then another 14, then another 14, then another 14. So if I can do that for 5 seconds, obviously if I multiply that by 5, 14 meters every second, but I do it for 5 seconds, I would go 70 meters. Okay, 14 meters every second. Ooh, number 5, my old car. Acura RSX can accelerate from 0 to 60 in 6.8 seconds. That was a sporty car, as you saw in my video. What is the acceleration rate of my car? So acceleration, change in velocity over time. We want to go from 0 to 60, right? So up to 27 meters per second. We're doing a metric here from a velocity of 0 at rest. And it took 6.8 seconds to do that. So we want to know what the acceleration rate is, meaning how much can my velocity change per second. So I got to do 27 divided by 6.8. And I get about 4. Can I round it? It's 3.97, folks. Did I call you folks again? That's okay. Meters per second each second, right? Or, I'm going to round it. That's about 4 meters per second squared, right? Because if I take meters per second, that's going to give me seconds squared. Okay, so that means my car can go 4 meters per second faster every second it's traveling. All right, number 6. What is the velocity of a car accelerating at 2 meters per second squared after 10 seconds? So again, we use our definition of acceleration. It's change in velocity over time. So here we know the acceleration. That car is going to travel 2 meters per second faster every second. So we know how fast we're going after 10 seconds. So you see we're going to do a little cross multiplying here. 2 times 10, so my velocity will be 20 meters per second at the 10-second mark. All right, a beamer can stop from 60 to 0 in 2.7 seconds, right? Braking is everything here, everybody. So we want to see what the acceleration rate is in going from 27 to 0. So here my final velocity is 0 minus my original velocity was 27. That's the metric equivalent of 60 miles per hour. And it only takes 2.7 seconds to brake. That's pretty good. So if I divide 27 divided by 2.7, I'm going to get negative 10 meters per second squared, which really means my velocity changes by 10 meters per second every second I'm braking. Okay. Notice we have a negative sign here. Right? We have a negative acceleration, which means my velocity is decreasing. Right? I'm losing velocity when I hit the brakes. All right, and our last one says when you're accelerating in a car, how does the distance change with time? Right? Again, if you go back to the video, that was my car, the Acura RSX, going down the street. And you saw when it accelerates, it might travel this much distance in the first time interval, and then travel a little bit more in the next time, and then the next time travel a little more than that, and the next time travel a little bit more than that. Otherwise, the amount of distance I can cover keeps increasing. So my distance, I can keep covering more distance per time as I accelerate. All right, thanks everybody. See you in class.